from similarity, okay, where it's given that some inputs are given to you. What's that? In the given figure, where a triangle is given to you, let's say if this is A, this is C, right? Then this is B, ABC is the triangle, right? Where angle ACB is given to you as 90 degree. This is given to you as 90 degree, right? So this is one of the data is given into the question, right? Apart from this, what else? And given that CD is perpendicular to AB, where CD is a point like this, lying on AB, and CD is perpendicular to AB. That means this angle is also 90 degree. That angle BDC, this angle is 90 degree, right? We need to prove what we need to prove. We need to prove CD square equal to BD dot AD. CD square equal to BD dot AD. What is this dot? Dot is basically multiplication, right? So this is the requirement. Now, here to solve this question, let us understand it very properly, right? What to understand? Here you can see we need to prove CD square is equal to BD dot AD. This is the requirement. This is the requirement which we need to prove, right? So here you can see CD, the sides coming into this is CD coming 2 times, right? After that BD, and after that AD, right? So these are the 4 sides which are coming to us, coming in front of us, right? So here what we can do, here all these sides CD, BD, AD. So CD is coming 2 times. CD is this side, right? CD is this side, and this is BD. This one, this is BD, right? And this is AD. So from this observation, what we need to prove, we can easily see whatever the triangles we should consider, that should have the sides AD, BD and CD, right? So AD is the side here AD. So AD is the side of which triangle? This is the side of triangle, this ADC, right? So first of all, this triangle should be considered without fail, right? To prove the similarity. That is because you can see AD is here, this side, right? And after that BD is the part of triangle BDC. So that's okay. This triangle will be the second triangle, right? This triangle will be the second triangle, right? Now, if to prove the similarity, unless and until you prove the similarity, you are not able to prove CDA square. You are not able to prove CDA square equal to BD into AD, right? So to prove the similarity of the two triangles, first and second, as shown over here, what we can do, we can simply, we need at least 2 angles of both these triangles equal. Okay, so to prove though that angles equal, what are those angles, just to identify? Because if we consider triangle, let's say AD, because AD is the side, so ADC, right? Let's take this way, ADC. So in triangle ADC and triangle, what will be the another triangle? This one, BDC or CDB. So what will be the sequence? Let us see how we are deciding it. So ADC, Then with this from the second triangle we will write BDC, but here you can see the D angle in the triangle ADC is 90 degree and BDC is in the triangle BDC also. This angle D, the central angle is 90 degree, right? So we can say this is the right sequence ADC and BDC, right? Here you can see for the two triangles to prove the similarity, to prove similarity similarity of the above triangles, what we can do, we need two angles. So first of all, this angle D is 90 degree, right? This is 90 degree because it's given into the question that CD is perpendicular to AB. So that's why this angle D is 90 degree. So we can write angle ADC is equal to angle BDC, and both of these angles are equal to 90 degree, isn't it? 90 degree. Now if this is proved to us, let me zoom a little. Yeah, I think it's better visible now, right? Fine. So if angle ADC and BDC are equal, then that means we have one of the criteria fulfilled, and this criteria is, let's say, criteria number one of the angle are equal. Now what is the second angle which can be proved from these two triangles, right? Because for similarity we need at least two angles. So by AA criteria we can prove the similarity. So here what we can see, if this angle is 90 degree and this angle is 90 degree, right? So we can say one of the angle could be 90 degree, but this will not happen over here because our triangle is BDC. This entire angle C is not taken over here, right? So what we can take, we if this angle is 90 degree and this angle is 90 degree, as we said, this angle D is 90 degree, which we proved over here. That is one of the point which we have taken. What is the second point? The second angle we need to prove from angle ADC, one of the angles should be equal to the another angle of BDC, and what's that angle? That need to be proved, right? Here you can do one thing. If this is angle 1 and this is angle 2, right, and let's say this is angle 3, right, then we can say 1 plus 2 is 90 degree, isn't it? Angle 1 plus angle 2 is equal to 90 degree. Can we say that? Because one of the angle is already 90 degree, this is already 90 degree, and sum of all angles of any triangle is 90 degree, 180 degree. So that's why if we are having this 90 degree with us, then sum of angle 1 plus 2 is 90 degree, isn't it? Then sum of 1 and 2 is 90 degree. So 1 and 2 is 90 degree. This is fine. What is another criteria? If you go to angle C, 2 plus 3 is also equal to 90 degree. So write angle 2 plus angle 3, this is also equal to 90 degree. Any doubt into this? Tell me. Earlier it was 1 plus 2, which was 90 degree, because this is complete triangle. In this entire triangle, all the three angles will add up to 180 degree, and one angle is known to you as 90 degree. That's why angle 1 plus angle 2 is 90 degree, this one. Similarly, since angle C is given to you as 90 degree into the question, so that's why we can say 2 plus 3 is also equal to 90 degree. And if these are the two equations with you, let us subtract both the equations. Then sine of this plus angle 2 from changes from plus to minus, and this sine of angle 3 changes from plus to minus, and sine of this 90-degree, which is written into green, changes from plus to minus. So when you subtract it, what you can see, this 90-degree cancelled out with this 90-degree, right? And this will give you into the RHS 0-degree, right? And into the LHS you can see angle 2 and angle 2. This will also be cancelled out, right? Because we are subtracting the equation, so that's why angle 2 will also be cancelled. So what we are having, angle 1, then angle 1, then minus, because sine of angle 3 is changed from plus to minus, minus angle 3 is equal to 0-degree. So this will give you angle 1 is equal to angle 3. This will give you angle 1 is equal to angle 3, right? This can be written, isn't it? This can be written because angle 1 minus angle 3 is 0. That's why we can write angle 1 equal to angle 3, right? So this is one of the star criteria which is fulfilled, because from these two triangles ADC and BDC, one angle was already equal, that is the central angle, that's you can see in the between D, that is already 90-degree, that is present into both the triangles. In triangle ADC, it's angle ADC which is 90, and when you consider the second triangle BDC, it's angle BDC which is equal to 90-degree, right? Now one criteria is fulfilled over here, right? This is one of the criteria or angle, one of the angle, let's say angle 1, which is fulfilled, right? This is one of the criteria which was fulfilled. And now here this is the second angle, that is angle 1 equal to angle 3. So here also another criteria is fulfilled, right? So from the AA criteria, AA, one angle this and another angle this, so we can write by angle similarity criteria, these two triangles ADC and BDC are similar. We can write triangle ADC is similar to what? Triangle BDC. B, D and C. Any doubt into this, students? I don't think so, but yeah, you can put up any time. So here you can see these two triangles are proved as similar. If these two triangles are proved as similar, we can write AD by BD, AD by BD. If these two triangles are similar, we can write the respective sides AD by BD is equal to CD by CD. CD by CD will not be taken. So this sequence of naming the triangle is not okay. Why not okay? Because if we are writing AD by BD is equal to CD by CD, and which is equal to AC by BC, this will prove that CD will be cancelled out when we are considering these two, and AD is equal to BD, right? AD equal to BD, but this will not prove this. So that's why we need to do a change. What's that change? We need to change the sequence of the naming. So here we have just put ADC as it is, ADC as it is, and this can be proved as similar to triangle. Now, instead of BDC, write CDB. CDB. Why we are doing it? Let me explain. Let me explain why I am doing it. because if I will change the sequence of one of the triangle, then you can see angle D will be same, that is angle ADC is equal to angle BDC. This angle is still this criteria which we have proved is still valid for this sequence, right? And angle 1 is already equal to angle 3, which is already we have proved here, right? So if we change the sequence, what will happen? We can write AD by CD, we can write AD, this AD by CD is equal to AD by CD is equal to CD by BD. CD by BD, isn't it? Can we write it? And if this can be written like this, if this can be written like this, then we can say AD into BD equal to CD into CD. Then in this case, we can write AD into BD is equal to CD into CD, which is equal to CD square. So in this way, we have proved our requirement. The only thing which we did the change later on, the sequence of the name of the triangle ADC will remain as it is, but instead of BDC, it should be CDB. Here, CDB. That's why, unless and until you will write it like this, it will not be coming. This what we need to prove. The naming AD by CD will not be equal to CD by BD, because you can see the first two letters here AD and first two letters here CD, right? So AD by CD here you can see is equal to CD by DB, because when we take the same sequence BDC, then what will happen? When we take the same sequence BDC, what will happen? You can see AD by BD equal to CD by CD, and in this way CD and CD will be cancelled out, right? So this will not giving the required result. So instead of taking BDC, you should take over here CDB, right? Instead of this, just change the naming of this triangle CDB. That's it, and rest of the proof will be as it is. Triangle CDB, triangle CDB, right? So what we proved? We proved the similarity of triangle ADC and triangle CDB. Instead of BDC, change the sequence, change B to C and C to B. Then only you will be able to prove this. Otherwise, you cannot. What we proved, just go it in the same way, yes, but here you are not able to prove as per the similarity criteria. This is the condition which need to be followed, and this was not fulfilled. So that's why we change the sequence of the naming of one of the triangle from BDC to CDB, and then the ratio of the sides of these triangles are taken, and we are able to prove it, right? And hence this is proved. This is proved, right? So everything with hello. So you are writing the correct statements about intermolecular forces is multiple correct, is are multiple correct. The potential energy between 2 point charges approaches zero more rapidly than the potential energy between ends. Oh, I'm not getting your proper chat inputs. Everything white. So you can just drop me a message with clear and complete statement. Okay. So then only I will be able to understand your query, because from the chat what you have written over here, I am not able to understand what you want to ask. Okay, or you want to discuss. Okay. So students, thank you so much for watching. And take care, happy learning. Just follow and just solve all the questions of similarity from the NCRT and all the books. Okay, they are very good books in the market. Okay, you can use different questions to solve it, and you should have the proper concept of the similarity. Unless and until you are having a proper command, you are not able to solve the different questions from similarity. The concept should be clear. So here how we have solved the question, and how we change the sequence, and why this change in sequence of the naming is required, we have explained it very clearly over here, right? I have explained it. So if you understood this question very clearly, then I can say you are almost okay with the similarity concept. Okay, and you can just go ahead and face any examination, even a skill examination or what. So the concept should be built up, right? So how we solved, I've explained each and every step. I hope you liked today's session. Thank you so much for watching, students. Take care. Bye bye. You can find it useful, you can just like and subscribe. Bye bye.